Hello, today we'll be talking about black hole and orbits, so let's jump right in. So to start, the purpose of this experiment is going to be to simulate the orbits of galactic objects and then predict an efficient path for a spacecraft that will use the gravity of said galactic objects. The fundamental physics principles that we'll be using is going to be that gravitational force equals big G constant times the masses of the two objects we'll be observing over the distance between the two squared. And second, we have the Newton's second law, which states that the net force equals the change in momentum over change in time. For results, we'll see that the black hole mass in part 1 is going to vary due to the change in momentum of the star varying as well. And in part 2, we'll see that the spacecraft took much longer to reach the figure 8 orbit than we wanted to due to human error. So for methodology, in part 1, we're going to generate a random star orbit around a black hole, and we'll use the star's momentum to calculate the black hole's mass. For part 2, we'll be making a spaceship go around in a figure 8 orbit around a moon and a planet. So how was the code developed? Well, the star was chosen for the system in part 1, and since we want to find the mass of the black hole, we can use gravitational force for that because it relates the two. And then this is going to be our last step because we don't know the gravitational force yet, but we can find it because the gravitational force equals the net force. So then we can use Newton's second law, which states that the net force equals changing momentum over changing time. So our first 4 lines is going to be dedicated to calculating that changing momentum over changing time. Well, the rest is going to be to make some arrows to be able to see the perpendicular and parallel components of the force. So for part 2, our moon was selected as the system first and then the rocket. In both cases, the planet was in the surroundings. And the reason why we want to choose the moon as system first is to find its orbit. And after we have the moon's orbit, we can find the rocket's orbit, which is going to depend on the moon's orbit. For our results in part 1, we'll see that the mass of the black hole is varying, and that is due to the change in the star's momentum. So the closer or farther away the star is from the black hole, changes the momentum of the star, which changes the mass of the black hole, which is not what we want. So it's an error. In part 2, we see that the spacecraft took a very chaotic orbit. It started around here and ended here. So technically it did reach a figure 8 orbit after a while, but it took way too long, and that was due to human error because the speeds were found by trial and error, and we found that making the speed in the y direction was making the speed in the y direction greater than the speed in the x direction was better, because if they were both the same, then the spaceship would just go around in circles. But with math, we can probably find a better way to get some better values. So what does it mean that the net force and its parallel and perpendicular component differ from those of the momentum? Well, numerically, the net force does equal the change in momentum over change in time, but for the net force, it requires knowing all forces, although for the momentum, we only need velocity. So for the net force, there can be an object very far away, but that will still have a small influence on the system. So what if we wanted to predict the motion of the entire system? Well, for that, we can use energy, because since there's nothing in the surroundings, energy is going to equal 0. And the motion can be found in the formula for the kinetic energy. So then we can take kinetic energy plus the change in the potential energy and equal that to the change in energy, which is going to equal 0. And that way we can find the final velocity if we know the initial velocity and the mass of the system. So in conclusion, the computational model predicted the black hole's mass incorrectly because of the change in the star's momentum. And in part 2, the spacecraft took way too long to reach figure 8 orbit due to human error. So thank you.